Okay, so this is going to be the 21st question in the Grand 75. This one is called add binary. So given two strings, A and B, we want to return their sum. These two strings will represent binary numbers, and so we will want to return their sum as if we were adding together two binary numbers. And just to refresh our memory on what binary numbers are, it's just another way of representing the normal base 10 set of numbers. It's just we're using a base of 2. So we have values 0 and 1, and then we move on to the next place if we go past that. So, with one value, we can do 0, and then we can do 1, but as soon as we go over, we need to go to the next spot, which would be over here. So this would be 3. And adding one more, we would add to the ones place, and this would be 4. So basically the way that it works is each place is 2 to some value. So the first one is 2 to the 0, second one is 2 to the 1, and each place represents these values here. So we have a 1, a 2, and an 8. That's going to give us 11. This is going to give us 27. And when we add them together, we should get 38. So let's see how addition works between two binary numbers. It's really the same method you would use when adding normal numbers, base 10 numbers, but we'll just illustrate it really quick. So 1 and 1, that exceeds our capacity, so we're going to have a carry over value, but we will put a 0 down here. Then 1 and 1 does the same thing, so we'll have a carry value, but we're going to take the old carry value and put it there. 0 and 0 contributes nothing, so we'll just put the carry value in. 1 and 1, same deal as before, so 0 carry over, 1 and 1, 0 carry over. This is technically a 0 here, and so we'll just put 1 there. So what this is 2 plus 4, which is 6, plus 32, which is 38. So that's how you add binary numbers. So that's all good, but Java kind of makes this problem harder than I'm sure Python would make it. So for one, we're going to have to go from the right side of the string because numbers, the least significant digit is on the right, and then the most significant digit is on the left. But another thing is that the strings could be different lengths, so that adds a level of complication. And of course, we need to be adding these numbers, but they're represented as strings. So that sounds pretty confusing in Java. How would we do that? But we'll go over the solution right now, and we'll start off first by creating those pointers. So int pointer a is going to start off as the length of a, and we don't do parentheses. We do not do parentheses for strings, -1. So if we think of the string kind of like as an array of characters, then we're going to start off at the very last index in that array. And we're going to do the same thing for b dot length -1. And then as we showed in the illustration, we are going to have to create a carry value that we need to keep track of. So we're going to say for as long as pointer A is greater than or equal to 0, or pointer B is greater than or equal to 0. And we're saying this because even if we reach the end of, say, this string, we need to keep going with that value. And we also might have a carry value, like in this case, that we would need to keep track of anyways. So we just use this one while loop to go over the entire length of just the longest string. And so we're going to start off by creating a sum called digit sum, which is going to represent the sum at the specific digit that we are looking at between the two numbers, the one that lines up. And because we don't know if we've run out of string A or string B, we will have to check each time. So we're going to say if pointer A is greater than or equal to 0, then what we're going to do is add to digit sum. We're going to plus equal the character at pointer A. So this will give us a character. But what we're going to do is subtract it from the character 0 to get the integer representation. So yeah, if 0 is the start of where the character set for numbers begins, then any value after that, when you take the difference from this and 0, it's going to give you the offset from 0, which is the appropriate value you are looking for. So we will continue on, do the same thing for pointer B, greater than or equal to 0. We're going to say digit sum plus equals b dot char at pointer B. Again, subtract that from 0. And actually, something that I forgot about, which is pretty crucial, we are going to have to create our own string. And we can't just do plus equals onto a string in Java, like we can in Python. So what we do is create an instance of a class called string builder. We can just say sb is equal to new string builder. And what this is it's basically like it's a collection of kind of any values of any type, and it's mutable, so you can keep adding to it. You would append to it sort of like you would an array list. So we will do that. We will add this sum right here. Okay, and then what we're going to do is append to that string builder or string that we are building. We're going to append digit sum mod 2 because actually this is the appropriate value right there, carry. We'll actually explain this in a little bit once we've finished the rest of the function. But once we do that, we also have to account for what our carry value is going to be, and the carry value is going to equal to digit sum divided by 2. We will also explain that in a little bit. Then we also have to make sure to move our pointers on, so pointer A, which I will go here for that, pointer A minus minus, pointer B minus minus, and then you have to check really quick if there is a carry left. If carry is, say, greater than 0, or if it equals 1, doesn't really matter. Then sb.append carry. Then we can return the string builder, but there's a couple key things. For string builder, we can only append, and when we append, we're adding to the end. But when you do addition, you don't go from left to right, you go from right to left. So the string is going to be added up properly, we just have to reverse it. So reverse, and then also string builder, as I said before, you can append like a character and then an integer and then a string, and it will still work into string builder. But once we call the method toString, it will convert everything that you put into it into a string, regardless of the type of it. So this should work. I will run it really quick, and then I will explain what these two mean. So let's just run it really quick. Let's see. Reached end of file while parsing. Missing a bracket there. Okay, let's just run really quick. A.length minus 1. Let me find out the issue really quick. Okay, sorry, so the issue was the parentheses belong in front at the end of the length when we're getting the length of a string. I need to get that straight. Dot length is used for just an array list or some collection of some kind. And then let's just submit really quick. And yeah, so that is the answer. And really quickly, I will try to go over why we do this. So there are 3 cases when we add binary numbers. So the 0 case, both digits are 0, so we can add 0 to it. So 0 mod 2 is 0, and then carry is 0 divided by 2, which is also 0. Okay. Another case is where we have a 0 and a 1. 1 mod 2 is still 1, so we would append that to the string we're building, and then 1 divided by 2 rounds down to 0, so we would have no carry value. Then there's the case where we have a 1 and a 1. So 1 plus 1, when we add that, we know that that goes past the maximum number we can have for a binary. So when we do mod 2, that brings us back down to 0. However, we have a carry value, and by taking the digit sum, which is 2, dividing by 2, we get our carry value of 1. And then it could also be the case where our carry value is 1, and we have 1 and 1 in both places in our strings. So we have a digit sum of 3. We take the 1 and the 1, and that will become 0. But we have the carry from before, which gives us that value of 1, which mod handles properly. 3 mod 2 is 1, and then our carry becomes our digit sum divided by 2. Because we had 1 and 1 in the places, we will create a carry, and this handles that properly. So this has been the solution to the 21st problem in the grind 75. This has been add binary.